At 0530 local time, a Russian Buyan-M corvette carrying 8 Kalibr cruise missiles in the Sea of Azov was preparing to fire on Ukrainian cities. While the mission had been relatively quiet so far, this would all change in a matter of seconds. Unknown to the Russian sailors, 7 Ukrainian drones were hunting them. The lead Rebecca accelerated to 400 km/h as Russian checkpoint guns opened fire. Tracers filled the dawn sky. Each 23mm shell could turn one drone into scattered debris. And that's when the real problems began. The checkpoint gunner couldn't see the drones, but he could hear them. He fired at the sound, walking his rounds toward that distinctive whine of motors. The lead Rebecca jked hard left. 23mm shells exploded around it, each one capable of instant destruction. The drone pushed to maximum speed, 432 km/h, screaming past before the gun could follow. But the damage was done. Gunfire alerted every Russian position within 10 kilometers. Messages spread through telegram faster than military radios. The element of surprise was gone. The operator's screen suddenly filled with static power lines invisible until the last second. The drone pulled up sharply, clearing 110,000 volts by just 2 m. Every instrument went haywire. Compass spinning wildly. Video feed flickering, flying blind for 3 agonizing seconds. Then a radio tower emerged from the darkness. The operator banked hard left, missing the guy wires by inches. Behind the lead Roba, 2 more followed 30 seconds apart, using the chaos to slip through. These were the Spear, designed to blind the ship's radar defenses. They had to succeed. 4 Bober drones took the northern route, slower at 200 km/h, but carrying heavier warheads. These were the hammer that would strike after the Rebecca's cleared the path. But those telegram warnings had already reached the next checkpoint. A Repellent-1 jammer waited, flooding control frequencies with 400 watts of electromagnetic noise. The lead-over screen went black, signal lost. But the Ukrainians had anticipated this. Pre-programmed waypoints kicked in. The drone switched to autonomous mode, navigating by accelerometer and optical landmarks, flying blind through the electromagnetic storm. 3 minutes later, the video feed returned. The Bober was exactly on course. But ahead, a BTR-82 blocked the highway. Its machine gun already firing in predetermined patterns. The operator dove into an industrial zone using buildings to break the line of sight. But those buildings sheltered Russian soldiers. Hearing drone motors, they poured out like an antil kicked over. The drone held 10 m altitude. At this height, the Earth's curvature creates radar shadows. A hilltop radar that sees 50 kilometers at altitude can only see 12 kilometers when you're skimming the ground. Physics became their shield from the BTR. The drones threat invisible corridors of safety while soldiers fired at sounds and glimpses. But statistics don't lie. Concentrated fire from a coordinated squad finally connected. The third Rebecca spiraled into the parking lot. Its warhead detonated on impact. 2 bores and 2 Rebecca's remaining. They couldn't afford to lose anymore. Then the lead Rebecca crested the final ridge. The operator's screen filled with something that shouldn't exist. The mission briefing had been catastrophically wrong. In 4 seconds, he'd have to make a decision that would either save the mission or destroy every drone. The Pantsir launched 6 missiles simultaneously. But these weren't ordinary surface-to-air missiles. These were Pantsir-ME anti-drone interceptors developed after commercial quadcopters humiliated Russian air defenses in previous encounters. Each missile weighed just 12 kilograms, but carried 200 tungsten spheres in a fragmentation warhead designed to create a donut-shaped pattern specifically for small UAVs. The spheres would expand outward at 1,800 meters per second, creating a lethal cloud 10 m in diameter, more than enough to splash these drones. As the Pantsir operator fired, he used ladder engagement tactics, launching missiles at staggered altitudes. First at 50 m, second at 30, third at 10 m, forcing the drone to fly through at least one fragmentation pattern. The fire control system calculated intercept points based on the drone's current trajectory, creating a 3-dimensional box of death. Each missile's proximity fuse sent out radio pulses, waiting to detect enough metal to trigger detonation. But the Rebecca's operator had studied Pantsir engagements extensively. He knew the missiles had a critical vulnerability, a 1.2-second arming delay after launch, a safety feature to prevent the warhead from detonating too close to the launcher. At 432 km/h, the drone covered 144 m in those 1.2 seconds. The moment he saw the missile launch flares, the operator pushed the stick forward, diving straight toward the Pantsir. The missile streaked overhead. Their proximity fuses still safety, unable to detonate even as the drone passed within meters. By the time they armed, the Rebecca was already below them, using the launcher's own safety protocols as a shield. The operator leveled out at 5M and lined up on the Podlet K1 radar. The system providing targeting data to every Russian launcher within 200 kilometers. The Pantsir's twin 30mm cannons opened fire, each barrel cycling at 5,000 rounds per minute. The gunner tried boxing tactics, creating rectangular zones of fire where the drone should be. But the fire control solution needed 1.5 seconds to calculate, 0.5 seconds for servo motors to aim. Then 1.5 seconds for rounds to travel 2 kilometers. Total lag 3.5 seconds. The drone operator changed course every 2 seconds, ensuring the operator was always solving an outdated problem. The Rebecca punched through and slammed into the radar antenna. The shape charge detonated, creating the Monroe effect. The Monroe effect occurs when a shape charge's explosion crushes a copper cone into a hypersonic jet, not melting it, but deforming it under such extreme pressure that solid metal punches through armor like a needle through paper at 7,000 m/second. The jet punched through the antenna array, the processing units, the operator stations, and out the back wall, finally dispersing into copper spray. The second Rebecca targeted the P-18 Spoon Rest early warning radar. The Pantsir switched to thermal imaging backup, but dawn created temperature inversion, a layer of cool air trapped under warm air. This causes thermal shimmer and false heat signatures as the air layers mix. The drone's electric motors generated minimal heat, maybe 10 degrees above ambient against the warming morning sea that still retained yesterday's heat. The drone appeared as a cold spot, then disappeared entirely when flying over cooler land patches. The thermal imager's processing algorithm, designed to track jet engines at 600 degrees, couldn't maintain lock on such a small temperature differential. The Pantsir gunner fired in desperation mode, predetermined spiral patterns starting at the drone's last known position and expanding outward. This water hose technique might work against helicopters that can't change direction instantly, but the drone could pivot 90 degrees in half a second. 5,000 rounds expended, 0 hits achieved. The Rebecca struck the P-18 dead center, eliminating 200 kilometers of radar coverage in an instant. With both primary radars destroyed, the corvette 4 kilometers offshore had lost its early warning network. Without the Podlet and the P-18 providing initial detection and tracking, the ship's own radar could only see 40 kilometers, giving it less than 2 minutes warning. The defensive shield protecting the corvette had just vanished. The ship that was preparing to launch missiles at Ukraine was now blind and alone. The corvette's radar detected the incoming drones at 4 kilometers. Ghost contacts that appeared and disappeared with each wave. The Russian ship faced an impossible problem: distinguishing 3-meter altitude drones from 2M waves. Both created radar returns of similar intensity. The Doppler shift that normally separates moving targets from stationary objects failed. When the drones flew at variable speeds between 80 and 120 knots. The computer's clutter rejection algorithm, designed to filter out sea spray, started filtering out real threats. Every third sweep, the drones disappeared entirely from the screen as the processor decided they must be false returns. But that didn't stop them from trying to use this weapon. The AK-630M2 duet system spun up with a mechanical whine. 10,000 rounds per minute erupted from twin 30mm cannons. The fire control computer tried to calculate paths using Kalman filtering algorithms. Kalman filtering algorithms predict where a moving target will be next by mathematically combing its past positions with current sensor data. Like trying to guess where a zigzag car is headed by averaging what you see with what physics says is possible. But the operators were throwing these calculations off by making random inputs every 2 seconds. The Duet system had been designed to engage P-270 Mosette missiles. 3,000 kilograms weapons flying predictable trajectories against 150 kilograms drones maneuvering randomly. It was like using a sledgehammer to hit a hummingbird. The computer needed 3.5 seconds to generate a firing solution. The drones change course every 2 seconds. The math never aligned. Undeterred at missing all their shots, the corvette deployed its PK-10 decoy system, launching clouds of chaff. Aluminum strips cut to half the wavelength of targeting radars. Each strip created a radar return larger than the drone itself. Within seconds, hundreds of false targets bloomed on every radar screen within 50 kilometers. Against radar-guided missiles, this would create an impenetrable confusion. Against drones guided by human operators watching through cameras, it created nothing but pretty sparkles in the morning sun. The operators ignored the light show and maintained visual lock on the ship. The corvette's TK-25E electronic countermeasure suite activated next, pumping out 200 watts across the spectrum from 20 MHz to 40 GHz. Against normal radio-controlled drones, this would sever the control link instantly. But the Ukrainian drones used frequency-hopping spread spectrum, jumping between 128 channels per second in a pseudo-random pattern known only to their operators. The jamming affected individual hops, causing occasional frame drops and pixelation, but never blocked enough sequential channels to break the link. The video feed degraded from 1080p to 480p. Annoying, but still usable. Sensing what was coming next, the corvette captain ordered evasive S-turns at maximum speed, but physics doesn't negotiate. The 949-ton vessel needed 15 seconds to change heading 30 degrees. The drone needed 50 milliseconds. The Rebecca operator recognized the ship's pattern and timed his approach for the steady period between turns. At 500 m, the operator switched to manual control. The radar mast filled his screen. 6 m of critical electronics. The duet cannons couldn't depress below -5 degrees. At 200 m range and 3 m altitude, trigonometry put the drone under their arc. Sailors with TK-25E machine guns fired from the deck, but they faced an impossible problem. The drone crossed their field of view in 0.8 seconds. Human eyes need 0.22 seconds to focus on a moving target, another 0.3 seconds to track it, and 2 seconds to aim. By then, the drone had moved 100 m. They were literally firing it after images burned into their retinas. The lead bore was aimed right at the ship's mast that held all its radars. Its shaped charge primed to destroy the arrays. The captain screamed for emergency launch procedures, trying to fire the Kalibrs before the ship was crippled. But the launch sequence needed 2 minutes for gyroscope alignment, target validation, and missile warming. The Bovers were 30 seconds away. The first Bover slammed face first into the mast. Instantly, every radar communication suite and data link on the ship went down. No longer able to fire their missiles, they were now a sitting duck. The second Bover dove toward the corvette's port side at a 30 degrees angle, its operator, aiming for the junction between frames 44 and 52, where the missile magazine sat behind 15 millimeters of steel plating. If they were lucky, the resulting explosion will detonate the Kalibr missiles in their cells and turn this ship into a fireworks display. At 100 m, the operator made his final adjustment, accounting for the ship's 8-knot drift and 3 degrees list from the hard turn. The shape charge needed to hit at exactly 90 degrees for maximum penetration. Too shallow and it would deflect. Too steep and it would waste energy. The operator had practiced this moment 500 times in simulation. But reality included variables no simulation captured. His hands shaking from adrenaline sea spray on the camera lens. The knowledge that missing meant friends would continue suffering under Kalibr bombardment. The Bober struck exactly at the missile magazine's forward bulkhead. Its shaped charge, a copper cone surrounded by explosives, created the Monroe effect, detonation waves focusing into a jet of molten metal moving at 7,000 m/second. The 15mm steel plate offered the same resistance as tissue paper. The jet punched through, spraying molten copper across stored ammunition and missile components. The second Bober also hit where missile handling equipment connected to the vertical launch tubes, hydraulic pumps, fuel lines, and electrical systems that turned dumb missiles into smart weapons. The explosion ruptured 3 separate systems simultaneously. Hydraulic fluid at 3000 psi sprayed across electrical panels, creating instant arc fires. Missile coolant lines burst, releasing toxic hydrogen derivatives. And most critically, the warhead safety interlocks disconnected, leaving 8 Kalibr missiles armed but useless. Despite the damage, the corvette didn't sink. It crawled into port 12 hours later with its superstructure blackened. Its hull opened in several places and smoke still rising from internal fires. Recovery would take 18 months minimum if Russia could source replacement components through sanctions. The 8 Kalibr missiles meant for Ukrainian cities remained unfired. Ukrainian operators sitting in bunkers 300 kilometers away had knocked out a warship costing $500 million using parts bought off of Alibaba. Bye for now.